couple types of factoring that we need to learn that are a little bit different than what we were doing on Friday. So the first is factoring by grouping. You may or may not have learned this in Math 1. I think I usually teach it to my kids, but I don't really think it's in the Math 1 curriculum anymore, so you may not have learned it. So factoring by grouping, I like because you don't have to guess and check. Factoring by grouping you're going to use when you have 4 terms. And not everything can factor with factoring by grouping, but some things can. So I'm going to teach you this method. So whenever we factor by grouping, we're going to use this when we have 4 terms. We take the first 2 and we group them together. We take the last 2 and we group those together, and we put a plus sign in between them. Okay? Then we are going to look for the greatest common factor for each group. So 2x to the third and 4x squared. 2 is my greatest common factor, and I can take out 2 x's with that as well. So I'll have 2x squared. And then left inside of the parentheses, I will have x minus 2. So you're dividing each one of those by 2x squared.
At this time, I need members of Status Club to report to the office. Members of Status Club report to the office.
Huh? Okay. All right. So, for the second group, guys, you got to pay attention. You're not with me today. All right. So, for the second group, greatest common factor here is 3. So we're going to divide both of these by 3. We're going to write that 3 out front. There was a plus. I added this plus sign right here. Putting that plus sign right here. We got the 3. And then when we do this, we also get x minus 2. Now this is what you want to happen. You want both of these right here to match. If they don't match, you can't do factoring by grouping. Although, it might be because you didn't pull out the correct greatest common factor, so look back for that. So, since they both have an x minus 2, essentially what you're doing is you're factoring out the x minus 2. So you're going to write the x minus 2 out front, because it's like you're dividing both of these by x minus 2. To factor it out, just like we did with the 2x squared and the 3. And then that leaves you with 2x squared plus 3 in the second parenthesis. So the one that matches, you pull it out front. Then the leftovers, they go in the second parenthesis. I like factoring by grouping because there is no guesswork. You just have to find the greatest common factor and you get the right answer. Let's check this one just so you guys believe me that that is the right answer. So if we multiply these together, first x times 2x squared is 2x to the third. Outers is going to give me plus 3x. Inners will give me negative 4x squared. And last, I'll get negative 6. If you write those in order, you've got 2x to the third minus 4x squared plus 3x minus 6, which is what you started with.
Report to the office. Members of FCS, please report to the office.
Okay? All right, questions? All right, so if we look at the second one, we're going to group the first 2, group the last 2, put a plus sign in between. Notice I put that minus right there in the parentheses. I always put a plus sign right there in between the 2 parentheses. That negative goes with the 20. So I'm going to factor out of the first one. What can I factor out? 5x squared. So I have 5x squared. That will leave me with an x plus 3 in the parentheses. Now, what can I factor out of the second one? 20. But if I take a 20, will I get x plus 3? I'll have negative x minus 3, right? So instead of taking out a positive 20, let's take out a negative 20. We can do that. So we get negative 20, and then we'll have, this time, if you divide both of those by negative 20, the negatives divided by the negatives is going to give you positive, so you get x plus 3, like that. And so x plus 3 and x plus 3, those match. We write the x plus 3 up front, and then leftovers 5x squared minus 20 goes in the second step. The x plus 3 doesn't have to be first. You can write that as 5x squared minus 20 times x plus 3. I just usually put it out front. Okay, questions? All right, here's our next couple. Okay, 13 looks pretty crazy with all those different letters, but we're going to do the same thing, group both. And what could I factor out of the first set of parentheses? 3 and an x. So I'll have 3x, and that will leave me with 5y plus 3 inside of the parentheses. What could I factor out of the second? Negative 4. What else could go with it? The r. So I'm going to have negative 4r, and that will leave me with 5y plus 3. And so since those match like we want them to, we'll have 5y plus 3 times 3x minus 4r. Okay. For the last one, group your first two, group your last two, put a plus sign in between. What could we factor out of the first one? Take a 4 and an m. So 4m. That'll leave me with 4n minus m. What about the second one? 7. So I factor out a 7. So that'll give me 4n minus m as well. So I get 4n minus m times 4m plus 7. Okay, questions? I do need to show you one more type of example that throws people off sometimes. So let me give you one more here. Example 15. Let's say we've got 2x squared minus, 2x cubed minus 6x squared plus x minus 3. That's a cubed right there. So let's say we had this. Alright, if we have this, we will group the first two, we will group the last two. What can we factor out of the first one? 2x squared. So 2x squared, and we get x minus 3. What can we factor out of the second one? There's nothing. But you have to put something. So what number could we factor out and it wouldn't change anything about that? 1. So we have to put the plus 1, x minus 3. So if you can't factor anything out, if it already matches, put a 1 in front of it, and let me show you why you've got to do that. So you got x minus 3 times 2x squared plus 1. All right. Let's say that we didn't put that 1 there, which would be wrong, right? Then we would have x minus 3 just times 2x squared, right? Because there's nothing there. So if you try to multiply that back, you've got 2x to the third minus 6x squared, and and that's all you get. You don't get the second half of what you need. So you have to, this would be wrong. You have to make sure that you put that 1 out front. Giant eraser gets me every time. All right, plus 1 times x minus 3. Make sure you put that 1 out front if there's nothing that will factor out. Okay, questions? All right, I want to add in just a few more examples, so you'll need to write these either on a sheet of paper or if you can fit them somewhere on that worksheet, you can. All right, so example 16. If I just have x squared minus 16, one of the main reasons that I had you guys do that worksheet at the beginning of class is because if you know how to multiply them together really quickly, it helps you recognize what to do whenever you have to factor them. So we've already done one like this because you can do this with just having sort of a 0 in the middle. But when you see something like x squared minus 16, that should send off a light bulb in your head that says this is a difference of squares. So when it's a difference of squares, you're going to just have the square root of the first number minus the square root of the second number. And then your second one will just be the same except for you change the sign in the middle. All right, you can do that the normal way factoring where you just need the middle terms to cancel out. But whenever you see something like this, you also can just do it really quickly in your head. Also, it's helpful if you have a more difficult problem like this. Like, let's say we have 24x to the second. Let's make that x to the fourth. Minus gotta make a good problem. Okay. Minus 54. Now right here, can we take the square root of 24 or 54? We cannot. But what's the first thing we always look for? Greatest common factor. We always look for that GCF, right? So, is there a GCF for these two numbers? There has to be. They're even. So I know 2 would work. Is there anything bigger? 6 will work. Here, so if we factor out a greatest common factor, if we have 6 times, 6 times 4x squared minus 9, I'm sorry, that's to the 4th power, not to the second. Like that, we can factor out that greatest common factor. Now, can we take the square root of 4x to the 4th power? Can we take the square root of 4? Yes, it is 2, right? When you take the square root of x to the 4th, I don't know how your teachers taught you last year, but taking the square root of x to the 4th, you've got 4 x's under here. I always tell my kids that the square root is like prison, and in order to escape, you must have a partner. But whenever you try to escape, one of the two is going to be shot and killed and just disappears. All right? So, whenever you have these two right here, they try to escape prison, one of them is killed, and it's just gone. All right, over here, these two try to escape prison, one of them is killed, the other one's just gone. Nothing is left in prison because they're either dead or escaped. So you get x squared for that. So when you take the square root of x to the fourth, you get x squared. So we can take the square root of that. Okay? Yeah. Yeah. Yeah, sometimes they would let both of them escape, and I would have to remind them they can't both escape. One of them's got to be dead. Also, like if you have, let's say we had this situation. This is not related to this problem. But if we had this situation, these two would try to escape. One of them would get shot. One of them would make it. But X and Y, they just stay there because you remember Leah? Why did they just stay there? They're not the same because they're in different prison gangs, and you don't help somebody in a different prison gang escape from prison. So the X's and the X gang and the Y gang are not going to help each other escape from prison. So this is what it would look like. There's a lot of other ways to think about that when we think about exponent rules. You also learned, like, when you multiply x squared times x squared, you add those exponents, so that would be x to the fourth. So the opposite of that, the opposite of squaring x squared is taking the square root, so it goes back to x squared. I think you also learn fractional exponents. So when you take the square root of x to the fourth, you guys remember how to do fractional exponents? This is a square root, which means it has an invisible 2 right there. So when you do fractional exponents, they're used for roots. It would be x to the inside number goes on top, outside number goes on bottom, because roots are on the bottom of a tree. So 4 divided by 2 is just 2, so that'd be x squared. There's lots of different ways of thinking of the square root of x to the fourth is x squared. Well, I'm not going to focus on it too much because for quadratics we're going to have x squared most of the time. Here, what's the square root of our 9? 3. So we've got minus 3 here, and then we have 2x squared plus 3 here. Now, a few key things for this. For you to be able to factor this way, you have to have things you can take the square root of. You also must have a minus sign right here. Because if you have a plus sign, it will not factor. Because whenever we have a difference of squares, we got a positive and a negative. So when we multiply for that last term, a positive times a negative has to give us a negative here. So if you have something like this, example 18, if you have something like this, 9x squared plus 25, you can take the square root of 9, you can take the square root of 25, but you've got a plus sign in between, so this one would be prime. You can't factor it if you've got that plus sign there. Because you can see, like you would think this would be 3x plus 5 and 3x minus 5, but if you try to multiply that back, you'll get 9x squared minus 15x plus 15x minus 25, and it gives you 9x squared minus 25, which would not be right. So in order to do a difference of squares, you have to have a minus sign in between the two numbers. Also, let me just throw this one in here because you'll get this mixed up. What about if I had this? What about if I had 25x squared minus 16x? What would I do on a problem like this? Is this a difference of squares? can I take the square root of 25? It is 5. What about the square root of x squared? It's just x, right? Can I take the square root of 16? Before, can I take the square root of x? I cannot. Square root of x wouldn't simplify to something. So when you see something like this, when you're missing the last term, that's when you do a GCF. Okay? What could you factor out of both of those? Just an x. So this one would be x times 25x minus 16. You can probably see how you would get this mixed up with that difference of squares pretty easily. So look out for that. If you're missing the last term, that's when you do a greatest common factor. It's when you're missing that middle term that you're going to do a difference of squares, if possible. Okay, questions? All right, one more special case, but this is not super special. So let's say I have x squared plus 6x plus 9. All right, you can factor this just like you would always factor it. It'll work perfectly fine. But if you happen to notice that you have an x squared, or something you can take the square root of here, and something you can take the square root of here, you could check to see if it is what we call a perfect square trinomial. Meaning those first problems that you were doing on that other worksheet, something, a binomial squared, x plus 2 squared, x minus 4 squared, something like that. So if I take the square root of x, I get x. If I take the square root of 3, I get 3. Because I have plus signs, I know I'd have a plus sign here in the middle, and I'd write that squared. Will that work? Okay, if you think of the shortcut that hopefully we're trying to start using, x squared would be x squared. Double the middle, so 3 times x is 3x, and double it gives you 6x, and then square the last, you get 9. You don't have to know any special rules for that. You can do just like always. You could say x and x, and then 9, we could use 9 and 1 or 3 and 3, so if you try 3 and 3, you can check 3x and 3x. That gives you 6x, so you know you factored it correctly. So this is your answer, although a lot of times it will be written like this, x plus 3 squared, instead of x plus 3 times x plus 3. Okay. Questions on anything? All right, so I want to give you guys a couple worksheets. One of them is on factoring by grouping. The other one is on special cases. So, okay, on the grouping worksheet, Make sure I really want to. Okay, grouping worksheet 1 through 15, odd. Do the odd ones. Because the teacher wrote 1 through 15 odd on the board and it don't do the odd. Okay, and, well, I don't have that one here. For special cases, let's do all of the evens on that one. Special cases should be a lot faster than the grouping. Okay. What I'm hoping is that on special cases, I want you to work towards being able to do those in your head without having to write anything down. You do not get the calculator on tomorrow's quiz. Tomorrow's quiz is on factoring and multiplying. Yeah. We'll have a quiz tomorrow on factoring and multiplying. The factoring will be normal factoring like we were doing on Friday. There will be a little bit of grouping. There will be a little bit of special cases, which really special cases can be done with, everything that's been on our notes so far. You'll also have a few where I'm asking you to multiply them together, which is like that first worksheet we did before we really started this unit. So what you had after your test on Thursday. So there'll be a little bit of that also. It will be on Canvas. I have not made it yet, but probably about 10. Something around there.